Okay, so in the previous video, we learned that we are going to parameterize the probability of success as P. That is the parameter we are, and the only unknown in our statistical model. And second, we learned that the mean equals to the parameter, right? So if you know the parameter, you don't need to calculate the mean. The mean is the same as the parameter, or in more general, you know the mean if you know the parameter. Now we are going to study the variance. So based on what I described, now I said the parameters fully characterize the distribution. That means if you know the parameter, you should be able to calculate the variance. So the variance must have a certain relationship with the parameter. Okay, then the goal of this chapter is to study this part is to study the variance, and we are going to consider another example. So think about your quiz. In a quiz, there is a multiple choice question, and simply I'll assume that there are 5 choices, and you randomly choose one of them. You choose an answer randomly, and if you choose a correct answer, then you are going to get 1 point. Otherwise, 0. So I will define a random variable x as the point you collect from a question by randomly choosing an answer. And of course, I will call success if it's correct and failure if it's wrong. And because there are 5 choices and you are randomly choosing one of them, the probability of correct answer is 20%, 1/5. Okay, so you may write this as x, or binary random variable x, follows binary distribution with the parameter 20%. Because the parameter is the probability of success, you put that number in here. Then you know everything about this binary distribution. So I said I'm going to study the variance, but to do that, anyhow, we have to study the mean first. We need to calculate the mean to calculate the variance. Okay, let's think about the mean. We have 2 outcomes and 2 probabilities. You calculate the mean. Okay, if you want to try this, take your time. Pause the video and take your time. And I'm going to go forward. So the answer is 0.2. It should be pretty simple. 1 times 0.2 is the probability weighted outcome, and 0 times 0.8 equals 0. So simply the sum is 0.2. And without calculation, you can simply use the fact that the mean always equals the probability of success for a binary variable. So without any algebra, you can just tell that the mean is 0.2, right? But either way, it's fine. But what's more important, what I want to show you here is the variance. So now you learned the mean is 0.2, and use this information to calculate the variance. Try this by yourself. Do the algebra. Okay, pause the video if you need more time. You should need more time, right? You should do it, okay? But I will resume. The variance, to calculate the variance, remember, we calculate the mean. That was the step 1. Then you have to calculate the deviation and the squared deviation, and then calculate the mean of the squared deviation. That's how you calculate the variance. Okay, if you follow that, subtract the mean, 0.2, and then take square. Then squared deviation is calculated this way. 1 minus 0.2 squared is 0.64. And 0 for outcome 0 minus mean 0.2 squared is 0.04. And then to these squared deviations, we multiply the probability. So 0.2 times 0.64 equals this, and this probability to this this outcome, this square deviation, you get this, and then finally sum these numbers, sum the weighted square deviations, probability weighted square deviation, you get 0.16. Okay, so you get a number, and what we are going to study here is to recover the relationship between the parameter 0.2 and the variance 0.16. Actually, I explained this. You had this question in quiz 4. I remember I recorded exactly same question in quiz 4 guide video. So you can go back there, and I told you the answer. What's the relationship between P and the variance? Anyhow, so to study this relationship, we are going to start from a more abstract case, just for a general P. So what we know is the assumption that there are two possible outcomes, 1 and 0, and that we assume that the probability of success is P, parameter P. That's all we have for now. And then the other probability is 1 minus P. And then from here, let's calculate the mean. 1 times P, 0 times 1 minus P. So P and 0. Sum is P, which is the mean. So again, this confirms what we knew. The mean should be the probability of success, the parameter. Okay, so this is natural, not surprising. But now let's think about the variance. So the mean was P. So deviation is 1 minus P and 0 minus P. And you take square of them, and then weight with the probability. So multiply the probability to the squared deviation. So for the first outcome, for success, the probability weighted square deviation is this guy, right? And for the other outcome, for failure, the probability weighted squared deviation is this guy. Probability times squared deviation. If you sum these two numbers, you are going to get the variance. The variance is sum of these two numbers. So now expand these terms, the quadratic functions, which is straightforward. So just expand the square term, then you get these, and p to the 3 canceled out, and it simplified like this, even further simplified like this. So we get a formula. In a binary distribution, the variance equals P times 1 minus P. I recommend you to memorize this as probability of success times probability of failure. There are only two possible outcomes. If you multiply them, that is the variance, right? This is very simple and interesting. Why variance becomes the product of these two probabilities. Let me so applying this rule, this is a general formula for any binary distribution. Then as you can see, without this much calculation, you can answer this question by simply multiplying these two numbers. 0.2 times 0.8 equals 0.16. That is the answer, right? The formula is also true in this example. And why is it so? So I'm going to explain the intuition this way. So think about this. Variance is about variability, or I would describe it as uncertainty. The larger the variance is, the more uncertainty the random variable has, right? Unpredictability or uncertainty is what the variance captures. Now let's think about the case where p is very close to 0. If the probability of success is close to 0, then actually the outcome is predictable. It is pretty certain. If the probability of success is close to 0, then you know that the outcome is very much likely to be a failure, right? Like you can expect if 99% failure, then the uncertainty is really small. So the variance is also very small. That is natural. Like in the other extreme, if you assume that the probability of success is close to 100%, then equally certain. So if the probability of success is 99%, then you can predict the outcome with 99% accuracy. It will be most likely to be a success, right? So when the probability of success is either 0 or 1, there is no uncertainty. It is always failure or always success. And as the probability increases, like moves away from 0 and 1, then the uncertainty increases. The maximum uncertainty is achieved when the probability is exactly half. When the probability of success is 50%, it's like coin flip. That is the most chaotic case. You cannot expect whether it is a failure or a success. That is the most uncertain distribution among like binary distribution. Most uncertain binary distribution. So that is when the variance is maximized. So this is a basic intuition. So the probability of success and the probability of failure must be symmetric, and they are maximized when they are half and half. So that simply its possible functional form is p times 1 minus p. So you may interpret this formula in that way. Okay. Okay. So as an introduction, we learned basics about binary distribution. So we learned binary distribution assumption and mean and variance. Pretty much simple. All the formulas are simple. And what we are going to do in the next video is to extend a single binary random variable to multiple binary random variable. It's like in this example, you are solving one question. You are choosing a random answer to one question. But in the next video, I will consider a whole quiz where there are 10 questions and you randomize all the answers to 10 questions. Then what is the distribution of your quiz grade? That is our main random variable. Okay, thank you for watching. I will continue in the next video. See you later.